In the name of Allah, the most gracious, the most beneficent. Today our topic is splicing of optical fiber cable. Let's move to the contents. What is fiber optic splicing? Why we use splicing? Advantages of splicing, comparisons, connectors, splices, splicing losses. What are the losses? And types of splicing. Two types: mechanical splicing, fusion splicing. Advantages and disadvantages of splicing. So what is fiber optic splicing? Fiber optic splicing involves joining two fiber optic cables together. The other, more common method of joining fibers is called termination or connectorization. Fiber splicing typically results in lower light loss and back reflection than termination, making it the preferred method. Why we use splicing? To increase the length of optical fiber cable, because manufacturers offer cables in limited length, usually 1 to 16 km. A link of 10 km can be installed by splicing several fiber optic cables together. To restore or repair the optical fiber cable underground when damaged, to join different types of cables together such as 48 fiber cable to 412 fiber cables. It is used for the permanent connection of the fiber optic cable where we don't need to change. Advantages of splicing. Number 1, splicing makes more accurately connection and lower attenuation. Number 2, splicing have lower losses, 0.02 decibel in fusion and 0.5 to 0.75 decibel in mechanical splicing. Number 3, by splicing we can make permanent connection. Number 4, no back reflection of light. Now we move to the comparison of splices and connectors. Connectors, which is non-permanent, but splices are permanent. Connectors are simple to use once mounted, but splices easier to seal hermetically. Connectors factory installable on cables, splices self-installable. Connectors are higher attenuation and back reflection, but the splices lower attenuation, lower back reflection. Now come to the topic, splicing losses. What are the losses of splicing? There are two types of losses. Intrinsic losses. These type of losses happen due to the differences in the fiber connection and variation in the fiber core and outer diameter. In other words, we can say that due to core diameter mismatch, NA mismatch, Fresnel reflection. If the core diameters, two fiber optic cables cores are of different diameters, then the splicing makes much losses. And another is NA mismatch, and third one is the Fresnel reflection. And second one loss is extrinsic losses. These losses happens due to nature of splicing itself. It depends upon the fiber and alignment and quality. Contamination, refractive index matching. In other words, we can say end separation, lateral misalignment, angular misalignment. It's due to the losses due to the man-made losses. Human errors are called the extrinsic losses. We can set end separation. We are not connecting the splicing both ends together in a proper manner. Lateral misalignment. The alignment is not good between the two cores of the fiber optic. Angular mismatch. The angle of the both fiber optic cores are not aligned, due to which the losses will occur. Now move to the contents. We have covered about the fiber optic, comparisons, splicing losses. Now we are moving to the types of splicing. There are two types of splicing, mechanical splicing and fusion splicing. So types of splicing, there are two types of fiber optic splicing: mechanical splicing, fusion splicing. If you are just beginning to splice fiber, you might want to look at your long-term goals in this field in order to choose which technique best fits your economic and performance objectives. In mechanical splicing, you see here in a diagram, mechanical splice means that we are manually aligning the both cores together. This is a core. This is a core of a one fiber cable, and this is the core of another fiber cable. We are aligning the sleeves in a best manner so that the data could be transferred, light could be transferred between the both cores in a proper way. Mechanical splices are simply aligned devices designed to hold the two fiber ends in a precisely aligned position, thus enabling light to pass from one fiber into the other. Typical loss is 0.3 decibel. It's just like we can say it's a mechanical splicing. Mechanical splicing, which is mechanically connecting the two cores of fiber optic in a single shell so that the light could transfer from one core to another core. But there is no fusion, there is no welding, or there is no heat alignment is has been provided to the both cores. That's why it's only mechanically it's these both are connecting, not in a real way. Mechanical splices works with both single fiber and multi-mode fiber. Mechanical splicing used for short distance local cable run. This mechanical splicing methods. What are the methods of mechanical splicing? There we use fiber lock mechanical splice. Quantity 6 splice per pack. There are the 6 splice in a pack of fiber lock mechanical splice. Mechanical splicing is an optical junction where the fibers are precisely aligned and held in place by a self-contained assembly. Not a permanent bond. It's not a permanent bond. These are mechanically combined. If we pull, both the ends will separate. This method aligns the two fiber ends to a common central line, aligning their cores so that light can pass from one fiber to another fiber core. Fourth step to performing a mechanical splice. Step 1. Preparing the fiber. Strip the protective coating, jackets, tubes, strength members, etc., leaving only the bare fiber showing. Bare fiber means the core of the fiber. The main concern here is cleanliness. The core should be very much clean so that no particle of the dust should come in between of the two cores. Otherwise, the light will not pass in a proper way and the losses decibel will increase. Step number 2, cleave the fiber. Cleaving the fiber is a process which cut the core of the fiber in a 90-degree angle. The function of the cleaver is to cut the core of the optical fiber at 90-degree angle for the best jointing purpose. For mechanical fusion and some connector system, cleave must be nearly perfect. If cleaving will not be perfect, the losses will occur. Step number 3, mechanically join the fibers. There is no heat used in this method, as I already said. Simply position the fiber ends together inside the mechanical splice unit. The index matching gel inside the mechanical splice apparatus will help couple the light from one fiber end to the other. Step number 4, protect the fiber. The complete mechanical splice provides its own protection for the splice. Now move to the topic fusion splicing. What is fusion splicing? The first one was a mechanical splicing and now it's a fusion splicing. Fusion splicing, the fusion means it's that uniting of different things into one by melt is called fusion, or combine the different things into one form by the melt, that's called the fusion. Joining the two things pieces or two ends of optical fiber is called splicing. Introduction of the fusion splicing is that the fusion splicing is one of the most useful splicing type. In the fusion splicing, the two ends of fiber are bonded together and then welded together the electric arc by splicing machine. Fusion splicing diagram is just like that. The two cores of the fiber are connecting and an electric arc. It's an electric arc into the machine which is providing electric heat to both the ends, both the cores of the fiber optic, so it gets melt and gets combined. It's just like into and converts into a single fiber core. In fusion splicing, a machine is used to precisely align the two fiber ends. Then the glass ends are fused or welded. It's also called a welding. Together using some type of heat or electric arc. This produces a continuous connection between the fibers, enabling very low loss light transmission. Typically losses are zero point 0.1 decibel. In mechanical splicing it was 0.3 decibel, but in fusion splicing it's 1 decibel. 0.1 decibel, sorry. Fusion splicing method. It's a machine, splicing machine. It's called the splicing machine. As mentioned previously, fusion splicing is a junction of two or more optical fibers that have been permanently affixed by welding them together by an electric arc. How it welds? Your question arises how it welds. The welding or melting in the fusion splicing is through the electric arc with the electrode. Whenever we melt the two ends of fiber, we first set the two ends of fiber at the mount and then press the button of electric arc which provides some heating for melting. Splicing machine during the splicing. It's a picture diagram. This is a picture which is connecting two fiber optic cables from different sides and connecting both at the center, and there is a electric arc which is providing heat to both ends of the fiber, both cores of the fiber, which gets melt, and due to the melt it welds together and makes a single fiber optic cable, and the latency is 0.1 decibel. And now here you can see this is a picture of an internal splicing machine on its LCD, which is or LED, which is showing both cores of the fiber optic cable. It's an internal alignment of both cores. Here the electric arc provides heat and both the ends gets together welded together and makes a single fiber optic cable. Filament Fusion System 2000 by Veterans. The FFS 2000 is a complete workstation with all fusion splicing procedures logically integrated into a single system that can be used to produce consistent splices quickly and efficiently. FFS 2000 is a machine which has been made for splicing of the fiber optic cables. This third generation fusion splicing workstation uses Veterans proven filament fusion technology. It's a technology, filament fusion technology, which is used to splice the fiber optic cables. Okay, let's move. Filament fusion technology to provide a convenient, reliable method of making high strength, low loss splices. This is the picture of a FFS 2000 workstation splicing machine. Here you can see it's a machine. There the camera fixed into the machine and the display is showing into the monitor. Video camera. The video camera or microscope attached inside the splicing machine, that camera display all the internal structure of the alignment of the two ends of the fiber to the user. In many cases, somewhere very high definition cameras are fixed in a splicing machine, and somewhere in some cases microscopes are fixed in a splicing machine. to show the high accuracy. Now the battery. Nowadays, battery is used to operating the splicing machine. That battery is to carry enough charge for few hundred splicing before the recharging. Factory version operate the splicing machine by power line or battery. Handheld core alignment fusion splicer. It's a simple splicing machine, little bit big from the mobile phones. Most compact, lightweight core alignment splicer in the industries. New graphical user interface UI to enhance ease of use. Transreflective LCD allows clear view even in direct sunlight. The new handheld FITEL S177A incorporates an improved heating design that cuts splice to heat time by 40%, achieving a 9-second splice time and 37 seconds heat time. Comparison between fusion and mechanical splicing and tips for the better splicing. Which method is better? The typical reason for choosing one method over the other is economics. Mechanical splicing has a low initial investment but costs more per splice, while the cost per splice for fusion splice is lower. The initial investment is much higher depending on the accuracy and features of the fusion splicing machine being purchased. The more precise you need the alignment, better alignment results in lower loss. The more you pay for the machine. As for the performance of each splicing method, the decision is often based on what industries you are working in. Fusion splicing produces lower loss and less back reflection than mechanical splice because the resulting fusion splice points are almost seamless. Fusion splices are used primarily with single mode fiber, where a mechanical splice works with both single and multi mode fibers. Many telecommunication and CATV companies invest in fusion splicing for their long-haul single-mode networks, but will still use mechanical splicing for shorter local cable runs. Since analog video signal require minimal reflection for optimal performance, fusion splicing is preferred for this application as well. The LAN industry has the choice of either methods, as single loss and reflection are mere minor concern for most LAN applications. Now, let's move to the advantages and disadvantages of the mechanical and fusion splicing. Advantages of mechanical splicing is low cost equipments are used, easy to align. And disadvantages of mechanical splicing, more cost per splice, more loss occurs per splice, then take more time to align. Advantages of fusion splicing is low losses, best joint, more reliable batteries are used, LCD displays in fusion splicing machine, mass fusion splicing machine. Disadvantages of fusion splicing is that very expensive splicing machine. Installation is also difficult. Be careful when you are applying heat from aux to fiber. All have been done. That's the final. And if you have any query regarding today's topic, please leave your comments in the comment box. Thank you so much. Please like, comment and subscribe to this channel.